Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about the storage of XML data. We will see that how to store data in a non-relational file in a relational database, how to map relational data to the XML, how to store the relational data in a relational database, and finally the mapping between this shredding and publication of XML data while native storage in the SQL format. XML data, as we know, is very popular in the web interface designing. So we need to sometimes store this XML data for our designing enhancement. Now this data can be stored in a normal file-like structure. Other than that, it can also be stored in a relational database format. So the relational database format storing needs that there should be some schema-oriented designing between the XML data. So we will discuss each of this case elaboratively. The first one is storing a non-relational database. Now when we are talking about a non-relational database, that means when the schema is not available for storing the data, then we should store the files or store the data in a non-relational format. Now to store data in a non-relational format, there are two ways. The first way is to store in a flat file. The flat file is nothing but a document file that will store our XML data. Well, it is absolutely important and simple for storing XML data in a flat file because it provides a more simple way to store the XML data. As well as we know that the XML tools are nowadays more enhanced and gives us many of the features, so it can do all the operations that we can perform on a relational database based on a non-relational flat file. Now the non-relational flat file had some disadvantage that we need to design it for the purpose that the schema is not available to us. So if there is any need for making a relation between two of the tables or datas, then it will become a hectic job for the programmer to do so. So we can choose the next one, that is storing the XML data in an XML database. The XML database is a database that is supported by the XML itself. That means the XML data can be stored into this database of every type it is supported by the XML data. Now it allows much object-oriented database faculties than we know that the object-oriented paradigm gives us to provide this data encapsulation, abstraction, and also this data inheritance and all. So we should support all of these features in this XML database. And also the XML database can perform the XML queries but not the declarative queries. To know about declarative queries, we will go to the relational section. But for the non-relational database, it just stores the data not within a flat file or in a document file, but in an XML-oriented database. That approach keeps similarities to the object-oriented paradigm. Now the XML database granularity provides us to go for fine one. That means the codes having the faults on this non-relational flat files can be achieved the wrong ones on this relational XML database. Now the XML database has some basic features like having support for the XML type data, and also there is no need to map the data to a normal document file that you have to do for a non-relational flat file. Now the XML database also supports the XML structures, the XML complex types, and other simple data types and attributes and all. So if it is not a relational purpose, then it is always good to store the data of XML in an XML database. For that, we need to create an XML database first and then store the XML data in that type of database. Now the non-relational database should support all forms of functionality. That means it should provide the room for enhancement for having the XML tools according to it and act on this one to have the results of the transaction security support and all. Now the next part is about the relational database. That means that it is often needed for any internet attractions or any web interfaces or any other user interfaces that we need a relation among what data we are storing. Say for we are going for an airline reservation system, so there is definitely a relation between seats, tickets, the offers that we have for the customers and all. So the relation can be maintained to the relational part on the database. If the database is not supported for giving relation and maintaining, then fetching a particular data will be quite enough tough for the programmer as well as the user on that basis. Now, when we store data in a relational database, then there should be an XML to relational part that will convert the XML data to the relational database. Now, the first way to store a relational database format XML data is to store it as a string. Now, while we store the data in such a string, we use the clop and blob features. The clop features generally specifically talks about the text string and then stores every tuple of a relational as a single string format. Say for if we are talking about a department relation that has got the department name, building, budget and ID of that particular department, then every tuple like this ID, department, building, budget pair will be stored as a string in this type of storing in a relational database. But the main problem lies that within this relational database is that the relational database in the stored string does not support that there is one relation to the tuple to another one in the string. That is, every tuple is stored as a different string in this one. So if we want to fetch all the departments, then we need to follow all the strings. So we cannot just put one query to achieve all the departments from this department relation if we store that as a string. Now an alternative we could do is that we know that XML deals with element. Now when we're talking about element, then every element that we are storing must store that according to its attributes, and the attributes will be stored as a different character or string. Now that the department name, the name, building, budget, the attribute wise we can store it as a string. Also as a tuple wise we can store it as a string. So if there is any query on a particular attribute, then we can have it within a single query of storing that XML data as a string. But both of the previous way is not convenient one because we cannot just achieve a proper relation among them. So we must store the XML strings to the actual relational database to store that and maintain the relationship among the tables or the relations. Now some database management system like Oracle support function indices for the XML data support. What is a function indices? It is different from a normal and simplest indices in that way that it provides the function or a particular function name as an index so that we can use the index or the function on a particular attribute or a set of attribute and get the result as the indices. So now only not the attribute name, we can use the function name also and the index to the relation. So that will become a more query and more declarative one while we are making the storage as a string on a clop feature. Now if we can store that in the function indices, that we are actually querying on a data and the result is being stored as an indices to the relation, so that we can know that this type of functions are very common to this relation, so we should store that as an indices so we can refer to the relations immediately. Now the storing as a string is not a convenient one as we have described, so we move on with the store as a tree representation. As we know that XML supports the hierarchical storing, hierarchical functioning of data. That means there will be a root node, then there will be the parent node, the children node, finally the children of the children node, that are the leaf nodes. So in this way we can store the data. While nodes being an element, and every element that belongs to it is a sub-element, and every property that we can attach to it is known as an attribute to that element. So if we consider an element as a node, then it has got 4 attributes or properties. The first is the ID. The ID, that means the particular ID for that node, that means the current node. Next is the parent ID. The parent ID is the identifier to the parent node, that means to which node this is the children or it belongs to. Next is the label. Label suggests for the name of that particular node. Name means that any name that you can give, the department name, instructor, building, budget, any of the name that we want to give the relation. And last is the type. Type means the particular type of the data. Is it an element? Is it a sub-element? Is it an attribute and all? So by this way of defining a node, we can say that this is an element, that means it belongs to the top one. Sub-element, that means it is a specialized one. Attribute means it will be attached with an element. So when we are dividing our tree-like representation, it is very easier to store that even if as a string. Now we can store our data not in a tuple-wise manner, but in a node-wise manner, where we can say that we are storing every value for the node, not for the tuple. Now we can use the clob and blob, both the features like the character lob, length of byte, or the binary files length of byte. Now both of it supports the storing in a tree representation on a parent and the sub-element basis. Now when we store data in a relational database on a tree-like representation, the main advantage is it can directly move to that XML data to a relational form. There is no need to explicitly convert the data that is in a document type to go in a relational form. We are maintaining a tree-like structure, means we are actually representing a schema. And whenever a schema is available to us, we can just store the XML data into the relational form directly without converting the document to the relational type. The next point that we have to consider is the map to the relations. Now we know that if the data schema is not available with us, that means if the data is stored as normally a string, then we need a mapping section to map the XML data to the relational form so that we can store the data to the relational form, and when we are fetching the data into the XML structure, we need to remap it. Now the mapping to the relation has got some checking or some procedure to do this. First, we need to define among the element and the attributes. Now, where to map the relations, we should consider that every schema or every tuple that we are considering for the attribute value should be of the complex type, and the element can have only the sub-element as the relation. If a relation has got any type or the values that is a simple type, so we have to consider is another simple attribute to the element, otherwise the sub-element can be referred to as a relation. So first we need to check that it is the root node or not. If it is the root node, then we just need to make it on the top in the relational form, just like the master relations. And now we should refer to the parents or other nodes on the children nodes, that this parent's ID or the root node's ID as the parent ID of the parent. Now first we are going with the root node, and then we are mentioning all the nodes. So if it is not the root node, that means it is somewhere in this internal node or the leaf nodes. Now if it is a leaf node, that means we are already have finished our application, and leaf node means that we can have the attributes along attached to it. That means if the simple type properties are there, then we cannot have that as another relation or the sub-element to that element. So we have to define that and attach an attribute to each of this element which have a simple type. The other thing we can do that, make the simple type and collection of it considered as a complex type, then make it as a relation. But it is not very much wise to do and advisable also, because there are some restriction of collecting the types on the attributes. Say for we cannot just collect the building names and the budget names because they are of two different categories. So now, if they are of the complex type, say for the university, they got the department, instructor, teacher, student, this much sub-elements, and each of the sub-element is of the complex type because the department has got the department name, building, budget, student got the student ID, name, total credits. So they are of different types. So we can have that as in complex type and make them a different relation. And if the relation also, that means they are belonging to the internal nodes. So the internal nodes can have the attributes, also can have the sub-elements. But the leaf node can only have the attributes, not the sub-elements, because they are in the leaf of the tree. Now, when we are creating a leaf node or an internal node, then we should create the 4 types. First, we need to define it with an ID that will define an uniqueness identified on that tree. Next, we need to mention the parent ID of that parent on that children belongs to. That means if it's a leaf node, then it can belong to either the root node or any other internal node. So we need to mention the parent ID. And finally, we should add all the simple types that the element has as the attributes to the elements. Now we have transformed our XML data to the relational form to store it in a relational database. Now that we know about mapping the relational data into this XML data and converting it to back, we need to know about publishing and threading. What do you mean by publishing? There is some way that we need to perform our documents or our database to be published in the web. And we cannot publish in the web in a relational form. We need to publish it in a XML data format. That means whenever we are storing or uploading our data in a web interface, that becomes in an XML data format, and this one is known as publishing. While threading is the opposite of publishing, that means when the web interface and we need to fetch the details and store it in our database, that means we are shredding the XML data to the relational form. Now there are several application codes to perform the publishing and threading the web interfaces to the user. But nowadays the application programmers are working hard to get that. We do not want to otherwise explicitly publish or shred data for the XML data and web interfaces. It will automatically publish, that means convert the data on an XML to the web and the vice versa on the applications itself. We do not write to again an explicit application code to perform this function. Nowadays the SQL, Oracle and many other database applications support this type of publishing and threading automatically by themselves. They allow an XML data or an XML type data to be attached to the application so that we can store the XML formats data explicitly in this type of application without being converting it to the relational form. So it just automatically convert the data from the XML to the relational form when it is necessary. Other than that, the XML data type is sufficient to store the XML data inside the application itself. Now the select clause will go for it in the SQL one and then check that the XML data type is available or not. If it is available, then we can store the data, and if it is not available, we can fetch the data from the XML and convert it to then our relational form. Now finally is the native storage for XML data. Some SQL and database management support provide a support or the native support for XML document being a part of this application. So publishing and threading is all about the native storage of an XML data. Either we can store the data in an XML data type, or we can choose the CLOB and BLOB, that means the character and binary formats data, to store the XML data. Now, while SQL can be performed on the XML data directly because the XML data type is embedded within this SQL, we can write on the hand the XML and the SQL side by side. Now, SQL supports the XML data type and the XML also support the SQL query. So the native support for an application for the XML data is becoming very popular nowadays and also very supportive in nature, because the conversion takes a lot of time and also a lot of memory to store the data in an explicit relational format and also in an XML data format. So the type XML supports for providing the XQuery and XPath in this declarative nature. That means the support for querying using the SQL as well as the XML go side by side and provide the select clause as well as the XQuery XML element clause, XML attribute clause to go in the SQL format. Now this way we can store the XML data in either the flat files or a non-relational format, or in a relational format, or in a tree representation, or itself within the application. So thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.